everybody. Today we're going to go through the test questions from test number 1. So we're going to start off with number 1. It says lines M and N are in plane A, and we need to find which answer choice is the converse of the statement that they give us. If lines M and N are parallel, then lines M and N do not intersect. So remember that the converse of the statement is when you switch the order of the hypothesis and conclusion. So instead of being if hypothesis then conclusion, it will change to if conclusion then hypothesis. So if we identify what the original P is, what the original hypothesis is, and what the original Q is, it makes things a bit more easy because now all we have to do is look for the answer choice that switches the order of P and Q. So instead of saying if lines M and N are parallel, instead of saying if P, it should say if Q. If lines M and N do not intersect, then lines M and N are parallel. So we can look through and see which answer choice says that. And that would be answer choice number 4 over here. Once again, all that happened is that P and Q switch spots. Okay. Number 2 says which statement is logically equivalent. And I'm going to stop right there and underline the word logically equivalent. Remember that logically equivalent refers to the contrapositive. Let me write that down, contrapositive. There we go. And the statement that they give us is if a triangle is an isosceles triangle, then it has two congruent sides. So remember that the contrapositive is if not Q, then not P. We have to both switch the order of the hypothesis and the conclusion and negate both. So the original hypothesis is a triangle is an isosceles triangle. And our original conclusion is it has two congruent sides. So we're looking for the answer choice that switches the order of P and Q and makes both the opposite, negates both. So it should say if it does not have two congruent sides, then the triangle is not an isosceles triangle. And I see that that's answer choice 2. For number 3, we're told that two angles are supplementary, and that means they add up to 180 degrees. It says that the measure of the larger angle is 40 degrees more than the measure of the smaller angle. So we can call the smaller angle, let's call it X, because we don't know what the smaller angle is. We're actually trying to find the measurement of the smaller angle. And let's call the larger angle X plus 40. That's because they told us in the question that the larger angle is 40 degrees more than the smaller angle. So add 40 to the smaller angle. Now we can make an equation that says if we add up the smaller angle and the larger angle together, then we get 180 degrees because they're supplementary. Combine your like terms, x plus x is 2x. Subtract 40 on both sides. We have 2x is equal to 140. And then finally, we'll divide by 2 on both sides. And we get x is equal to 70 degrees. It asks for the measurement of the smaller angle. The smaller angle is the x value. So we found that the measurement of the smaller angle is 70 degrees. For number 4, it says, it gives us some information about a line segment AC that's split into two parts, AB and BC. And we need to answer is B the midpoint of AC, and we need to explain our answer in words. So it doesn't matter how many words you have or what exactly you did here, as long as you had the correct answer and you had some explanation to back it up or some work to back it up. So let's go over one approach for doing this. So first I'm going to just draw a diagram to represent the situation. So I have AB is 3x, I have BC is x plus 5, and I know that the whole line segment AC is 24. So let me draw a diagram. So the whole line segment of AC is 24. Let me draw that. B is somewhere along the line segment. I don't know exactly where. And we know that AB from A to B is 3x. And we know that BC from B to C is x plus 5. So we can find the x value, and then we can see if it does, in fact, split the line segment into two equal parts. So there's many ways that we can do this, but what I'm going to do is I'm just going to make an equation that says if I take AB and I put it together with BC, I should get the whole line segment AC, which is 24. Combine my like terms, 3x plus x is 4x. So we have 4x plus 5 is equal to 24. Subtract 5 on both sides. We have 4x is equal to 19. And if we divide by 4 on both sides, that doesn't work out to give us a nice number. But if you put that into your calculator, that's approximately, well, not approximately, exactly 4.75. So let me take the x value and let me actually plug in to find what AB is and to find what BC is. So 3 times 4.75, when I put it into my calculator, I get 14.25. And now let me put x plus 5 into my calculator. 4.75 plus 5 is 9.75. So no, B is not the midpoint because it does not split the line segment into two equal parts. AB and BC have different measurements. You do need to have something written in words for this question. You can write B is not the midpoint of AC because it does not split the line segment into two equal parts, and that works just fine. Number 5 mentions a right triangle, and a lot of people didn't draw their right triangle on the test, but whenever you some kind of object, a triangle, a line segment, any of that stuff, and you don't see it, your best option is to draw a diagram of the situation. It tells us that the legs of this right triangle measure 9 and 12, and it asks us to find the length of the hypotenuse. So you need to be using the Pythagorean theorem in order to find the length of the hypotenuse, which is a squared plus b squared equals to c squared. It was written on the board while you guys were taking the test as well. So I'm going to plug in 9 for one of the legs. I'm going to plug in 12 for the other leg, and we're solving for c. So we have 81 plus 144 is equal to c squared. 81 plus 144 is 225. And to get c by itself, we are going to take the square root of both sides, and we get c is equal to 15. So the missing side of the triangle is 15. For number 6, we need to name an angle that is complementary to angle BOC. So we need one that adds up to 90 degrees when you put it together with angle BOC. So from looking at the diagram and knowing that complementary means adds up to a right angle, I know that AOB is a 90-degree angle because I see the box there. So I know that this entire angle BOD is a right angle as well. So I know that if I put COD that I highlighted in green together with BOC, if I put the blue and the green together, I should get a full 90-degree right angle. So if angle COD is an answer choice, that would definitely work. I see it is in number 3, answer choice 3, but there's also another angle that it talks about in that answer choice, angle AOE. Taking a look at my diagram, angle AOE is a vertical angle to angle COD. And remember that vertical angles are always congruent to each other. So the correct answer choice is angle 3. COD together with BOC makes a right angle. And since AOE is congruent to angle COE, that works as well. Next page. In the figure shown, the measure of angle AED is 117 degrees. Which of the following statements is false? Well, before I get to that, let me fill out what I know. So BEC is vertical to AED, so that's 117 degrees as well. And I know that AEB and DEC are vertical angles, and this angle plus this angle is 180, and this angle plus this angle is 180. So that makes this angle here have to be 63 degrees, and this one as well. So looking at the answer choices, I clearly see which one is false. The measure of angle BEC is not 63 degrees. We just filled out definitively that was 117 degrees because it's vertical to the other 117 degree angle, angle AED. Okay, number 8. So in number 8 here, we're told that MO, ray MO, is bisecting angle LMN. So as soon as I read the word bisecting, I'm going to think splits the angle into 2 equal parts. I'm going to just head over to my diagram and just mark that the 2 parts of the angle are congruent to each other. We have the 15x minus 42 part, and we also have the x plus 56 part. Since both parts of the angle are congruent to each other, I'm going to set up an equation that says 1/2 of the angle is equal to the other half of the angle. So let's set that up right now. 15x minus 42. That's a little bit messy. Let me fix that. Minus 42 is equal to x plus 56. So I'm going to subtract x from both sides, and I get 14x minus 42 is equal to 56. I'm going to add 42 to both sides, and I get that 14x is equal to 98. And then finally, I'm going to divide by 14 on both sides, and I get x is equal to 7. So we can't stop there because the question says to both solve for x and to find the measurement of the whole angle, LMN, which is the entire angle here. So let's figure out what each half of the angle is, and then we can add it together to get the whole angle LMN. So I'm going to plug in to the right-hand part of the angle that's labeled x plus 56, because that's a little bit simpler to plug into. All we need to do is 56 plus our x value of 7, and I get 63. Since each half of the angle is congruent, since we have a bisector, I know that both parts of the angle do measure the same amount for sure. So if this half is 63, this half is 63. And 63 plus 63 makes 126. So I know the whole angle, LMN, is 126 degrees. So there's multiple ways to do number 9, and it says only an algebraic solution will be accepted, but any solution would get you credit on this question, and any solution was taken for this question, including guess and check. Anything goes for this question, whatever gets you to the answer. So I also algebraically, but you can definitely do it another way if you'd like to. So I'm going to set up some equations here. I know that these two angles together make a straight angle. And I also know that these two angles together make a straight angle. So let me set up some equations that say that. So the two angles in blue, 110 and 3x plus 2y. If we put them together, we should get a straight angle, 180 degrees. And in red, we have a 70-degree angle. And if we put that together with the 9x plus y angle, we should get a straight angle as well. So now I'm going to look to cancel out a variable. So the way I'm going to do that is I'm just going to take this second equation here, and I'm just going to multiply the whole thing by 2. That way I can get a 2y here, and then I can cancel out the y variables since I'll have a 2y here and a 2y here. If I subtract 2 and 2, I can get 0. So that's kind of my plan. So multiplying by 2, I get 140 plus 18x plus 2y is equal to 180. Let me just move down my blue equation so we can see both of these together. No, not that one. My blue equation. That's what I multiplied. There we go. My blue equation. Perfect. Okay. So all I'm going to do now, and let me scroll down to give myself a bit more space. All I'm going to do now is subtract the two equations. 2 minus 2 is 0. And that was the whole point of what we're doing. Now we can kind of fill in the rest. So 140 minus 110 is 30. We have 18 minus 3. That's 15. 15x is equal to 180. Now we only have one variable, so we can definitely solve for x. Subtract 30 on both sides. We have 15x equals to 150. And if we divide both sides by 15, we get x is equal to 10. So we found one of the variables. And once we have one of the variables, finding y is not as difficult. We can go to any of the equations that we had set up before, and we can plug in the x value, and we can see what the y value is. So I'm just going to go over here to the side, and I'll just rewrite one of them. So one of our equations, the one that we started with in blue, was that, green, was that two angles in blue, 3x plus 2y, and 110 added up to 180 degrees. If I plug in 10 for x, 3 times 10 gives me 3, plus 2y, plus 110 equals to 180. Combining like terms, 110 and 30 gives me 140. So I have 140 plus 2y equals 180. If I subtract 140 from both sides, I get 2y is equal to 40. And if I divide by 2 on both sides, I get y is equal to 20. And there I have it. They work out to very nice numbers. I have the x variable, what it is, and the y variable. Once again, some people didn't do this algebraically. They did it with guess and check because they knew what, two angles needed to add up to, that they needed to add up to a straight angle, or that there's also vertical angles that you could have used here that, the vertical angles equal each other, they're congruent. It doesn't matter if you used guess and check, as long as you got the right answer, you got credit for this question. And this question was also graded very leniently. So even if you didn't get the right answer, it was graded very, very leniently. Okay. Now I'm going to move all this over because I need some space to do the construction. Okay, so in number 10, we're going to construct a perpendicular line through point C. And our line is going to be perpendicular to the line that they give us, ACB. So a lot of people were confusing the perpendicular line construction with the perpendicular bisector construction. Here we have a line, ACB is a line, so we can't bisect a line. So if you did do the perpendicular bisector construction, it is not correct because it's not even possible to bisect the line. Okay, that would receive half credit if you mix those two up. So what we're going to do is we're going to start off with our compass point on the point that we're given. So that would be point C here. That's the point that we want our line to pass through. I'm going to open up my compass. It doesn't matter how far I open it up. The only thing that matters is that when I swing my arc intersects, my arc intersects the line in two spots. So I see that it does intersect in two spots, so we're all good here. I'm going to take my compass and I'm going to put it on each of those intersection points. I'll put it on the left one first and then the right one. So I'm going to pick my compass up and I'm going to put it on the left intersection point. And I'm going to open my compass up. It doesn't matter how much, a random amount, or pick a random hole on your red compass. And I'm going to make an arc that goes above. Using the same distance or the same hole if you have a red compass, I'm going to turn my compass around and put it on the other intersection point and make the same exact arc. And check it out. I have a point where the arcs meet. I can get out my straight edge and I can draw a straight line right through the intersection of those arcs. And in theory, it should be perpendicular to line ACB and it should pass right through point C. If yours almost passes through point C, it doesn't exactly pass through point C, you got full credit. That's good enough. We try to be as precise as possible. You shouldn't be extremely far off. You should be pretty close to passing through point C exactly. Okay. So here we have it. We have our line that's perpendicular to the line that we started with. For number 11, it says in the diagram, AOB is a straight angle. So I already know that if I take all three of the angles here and I add them up, that should give me 180 degrees. They tell us that we have a 40-degree angle and we have an X degree angle, but then they tell us that the angle that we're missing, angle DOC, is 8 more than X. So that's more than is addition. So that's 8 plus X. So all I'm going to do is set up an equation that says if I take all three of these angles and put them together, I get the entire straight angle. I get 180 degrees. So let me do this on the side. So I have X, that's this angle on the left, plus the middle angle, which is X plus 8, X plus 8, plus the angle on the right, which is 40. Is equal to 180 degrees. Combining my like terms, I get 2x plus 48 is equal to 180. I'm going to get out my calculator so I can subtract both sides by 48. So I have 180 minus 48. And I get 132. So that's 2x is equal to 132. And all I have to do next is divide both sides by 2. And I get x is equal to 66. And all they wanted us to do was find x. So x is 66 here. number 12 wants us to construct the angle bisector of the angle that they give us. So let's do it. I'm going to start by putting my compass on the vertex of the angle. Let me flip my compass around just to make, oops, I'm moving the whole paper here. Let me flip my compass around to make life easier for me on this screen. Okay. So I put my compass point on point B, the vertex of the angle that I'm bisecting, and it doesn't matter how wide I open my compass or what hole I pick. I'm just going to swing an arc that intersects the angle in two spots. So I have one intersection point here and one intersection point here. I'm going to take my compass and I'm going to put it on each of those intersection points. So I'll put it on the top one first. Doesn't matter how far I open my compass. Using the same distance or the same hole if you're using a red compass, I'm going to put my compass point on the other intersection point. And I'm going to make the same exact arc. You should see a point where the arcs meet. And that is where we're going to draw the bisector through. Oh no, there we go. Let me get my straight edge out from the vertex right through the intersection of those arcs is where we draw that bisector. And that bisector should be splitting the angle into two equal or congruent parts. Let's move it along here. So 13, I think the easiest way to do this is graphically. So I'm just going to set myself up here. I'm going to make a little XY coordinate plane. They don't give you one here, but you can make your own. Not too difficult. There we go, all set up. So it tells me that the midpoint of line segment AB is 2, 4. So that's the midpoint of the line segment. Interesting. 1, 2, 1, 2, 3, 4. So I'm going to label that M because it's the midpoint of AB. I don't know what A is, I don't know what B is, but I know the midpoint. Oh, look, they tell us the coordinates of point B are 3, 7. So that's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It's right here. And I need to find the coordinates of point A. Remember, the midpoint is the middle point that's exactly in the middle of the line segment. So it should be an equal distance from each of the endpoints. So to get from the midpoint to one of the endpoints B, we need to go up 1, 2, 3 boxes. So I'm going to put up 3. And we need to go to the right 1 box. So that movement should be the same to get to the other endpoint, just reversed. Instead of going up 3 and right 1, we should be going down 3 and left 1. So let's try it. Down 1, 2, 3. Oops, oh no. My computer has a life of its own. Okay, so that's down 3. 1, 2, 3. And left 1 box. And that should be the point A that we're looking for. It does have the coordinates 1, 1. And that's it. If I do take my straight edge now and connect points A and B together to make line segment AB, M should be the point exactly in the middle of A and B, if A is at the point 1, 1. The last question here looks similar to the previous one, but it's asking us to determine the distance. So we need to use the distance formula. A lot of people didn't remember the distance formula on the test, and that's okay, because the distance formula is hard to remember. Oh no. That's why we also learned about how if you forget the distance formula, you can also use the Pythagorean theorem. So I do want to just show that. So point A is -1, 1, 2, 3, -1, -3. So I'm just going to graph it and label that point A. And point B is 5, 5. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's right up here. That's point B. Okay. So I'm just going to connect those with my straight edge if my mouse will decide to work. So I'm going to connect with my straight edge from A to B. And I just want to form a right triangle. So I'm just going to connect to make a right triangle here. Okay. Now if I count the boxes up and down, 1, 2, 3, 4, 5, 6, 7, 8. From here to here, there are 8 boxes. And if I count the boxes from here to here, there are 1, 2, 3, 4, 5, 6 spaces. So now all I need to do is use the Pythagorean theorem, and I'm solving for the missing side over here. So I can plug into a squared plus b squared is equal to c squared. So for the legs, I can plug in 8 and 6. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. And if you take the square root of both sides to get c by itself, we get c is equal to 10. And that's it. The length of the line segment is 10. So if you can't remember the distance formula, don't worry. The Pythagorean theorem works too, especially if you have a graph to work with. Hopefully this helped you guys understand some of the questions that you got wrong.